Thank you.
Yeah.
Wait,
Okay.
so g of 5 is the answer? Or when x equals 5, that's the maximum?
Correct. So 11 minus 9/4 pi.
Okay, and to get the point, do you have to do all that work?
Okay, so basically in the rubric, let's see, I guess I should have opened up the rubric as well. Let me find it. Oh, that's not it. All right, sorry about that. All right, so in that particular problem, okay, it says it's worth 3 points. 1 point is for stating that g prime is equal to f of x. 1 point for identifying x equals -1 as one of the candidates for maximum. So obviously you have to recognize that it's an absolute or that it's a relative max somehow. And then answer with justification. So you don't necessarily have to show the g of -2 and the g of 1/2 because those are minimums, but you do have to have justification, right? So stating this value and stating that value would be sufficient in my opinion.
Why do you do the critical, like, what's the difference between the critical number test and then like the sign analysis for the minimum maximums?
All right, so if I was just doing critical number test, I would have had to do all 4 of these because I'm not paying attention to whether or not, the derivative is positive or negative in any particular intervals. I'm simply saying that the extreme value theorem states that a function that is continuous on a closed interval will have an absolute maximum and an absolute minimum, and it will occur at a critical number. And so I've identified the critical numbers of -2, -1, 1/2, and 5. And then if I just find their y values, I can compare them, and I know which one is the absolute max and which one is the absolute minimum. Does that make sense?
Yeah, I think so. I just I did like the sign analysis thing with the little graph thing. So I was wondering if there's any specific reason for like not doing that.
No, I mean, the sign analysis is fine as well. Now, there's another way that you might be able to reason through this without actually gaining those values necessarily. So if I'm back, if I'm looking at, if I'm looking at just the graph, right, without knowing this value, and without knowing this value, do I know where the maximum occurs? And the answer is yes. So if this area represents how much G has increased, right? This area represents how much G has decreased, then this area represents how much G has increased again. Certainly, it increased a little, decreased a little, and then it increased a whole lot. So certainly, the maximum is going to occur at 5. Does that make sense?
Yeah, that's what I did, and I didn't really show any work. So like, I don't know if I would.
Yeah, you might only get like 2 out of 3 there if you didn't have any statement, about, like, even if you just said, like, if you said the integral from -2 to 1 is less than the integral from -2 to 5, therefore 11 minus 9/4 pi is the maximum. That would probably be sufficient. Mr. Dybus, you want to chime in on that question?
Yeah, I mean, I would err on the side of having the critical number test. Going back to sort of what Tess said with the sign analysis, that sign analysis is going to tell you, like, that you have some form of a relative maximum, relative minimum, but knowing if it's like the absolute, either, as Bono was just explaining, like visually you can sort of see that upon inspection, but you don't really have a way of showing that so that AP knows that you know it. Critical number test just shows you that quite definitely.
All right, thank you.
Mm-hmm. Okay, so that's part C. Anything else with part C?
Luca, did your question get answered? Oh, sorry.
Do we need Never mind.
Yeah, I was just wondering if you needed the sign analysis, but he answered the question. So
All right, and then somebody else was asking, Alex, maybe?
Yeah. Do you know exactly how many questions are on the FAQ?
So we're going to talk a little bit more about that in the coming weeks. But basically, we're going to have, it's going to be 45 minutes of multiple choice. Now, initially, I just thought that that was going to be like 3 multiple choice questions, or sorry, not multiple choice, 3 free response questions, you know, because in the past, there have been, you know, 15 minutes per free response question. So I just assumed 3. But that's actually not going to be the case. And so we're going to talk a little bit more about how it's broken down. But what is it, 25 minutes and 20 minutes or?
Yeah, I think it's 25 and I thought it was 25 and 15, but that doesn't add up to 45. So
No, let me pull it up. I've got the website here open. If it'll work. All right, so all right, so this is, so let me change what I'm sharing with you guys, and you guys can see this. All right, so does everyone see my screen right here? Okay, and so this is the information that they're giving about the current state of the AP test. So the exam date is going to be on Tuesday, May 12th. So that's a week later than it was going to be. And it is going to be at Central Time, 1 p.m. Students will have 25 minutes to read and to respond to question 1, and then 5 minutes to upload their response. So that would include like taking a picture of your work and then submitting to the College Board website. And then after uploading response to question 1, students will have 15 minutes to respond to question 2, with an additional 5 minutes to upload their response to question 2. Once their response to question 1 has been submitted, they cannot go back to it. So you're going to have 25 minutes for one question and then 15 minutes for another question. And so it's going to be 60%, 40%, and it's going to be, you know, free response question, but that 25-minute question, I think is going to kind of be like a super FRQ, because in the past, all of the FRQs have been like 15 minutes on average. And so if this is 25 minutes and it's worth 60% of the grade, it's probably going to have a whole ton of different parts to it. Any questions about that? So another couple things down here. It says for students who prefer to type their responses, I highly doubt anyone is going to be interested in typing their response for calculus. But then it says questions on the 2020 AP exam are designed such that a graphing calculator or other calculator is not required. So really the way that I look at it is we're looking at non-calculator questions, of course, because they're not going to require it. However, the use of a calculator is allowed, right? But you know, that's really not a concern. All right. No arithmetic or calculations will be required beyond what can readily be done with a pencil and paper. Okay, so it's important that you remember you're not even going to have to simplify any of those, right? AP Calculus AB students are advised to submit unsimplified numeric answers in order to avoid risking arithmetical errors not related to calculus, but also not related to like the time that you're actually going to spend. You don't want to spend that extra time doing that work. Okay. Any questions?
Mr. Bonarigo, a question in the chat.
Sure.
Are the exams, or do you think the 2 FRQs are going to be more difficult than in years past? I would say probably not the 40% one, but the 60% one.
I do think it's going to be more difficult, just 'cause it's going to have extra parts and things, but I think individual parts are going to be pretty reasonable, as individual parts have been in the past. So like when you look at like this particular question, and we haven't even gotten to part D yet, part A is pretty reasonable. Part B is pretty reasonable. Part C, I think, is still reasonable. It's just, a little bit more challenging, right? So you might see, let's say that this 25-minute question has like 6 parts, or something like that. I personally believe that like 4 of the parts are going to be totally reasonable. If you're doing this practice and you're paying attention, I think you're going to be in a great position to do just fine on those. Yes, they're going to have some more challenging parts, because they want to distinguish, they need to distinguish a person who, is going to get a 5 from a 4 from a 3. But there's certainly going to be ones that, we're going to touch on in our practice over the next month. All right, any follow-ups? More questions? I guess I don't have my chat window open.
Oh, you're good.
Okay, all right. So let's go on to part D then. All right, so part D is pretty reasonable. I mean, it just says find the limit as x approaches 1 of 10 to the x minus 3 f prime of x over f of x minus arctangent of x. All right, and so we're simply I mean, on my initial glance, I was expecting maybe a L'Hopital's rule question or something like that, but it's not even that, right? When you plug in, you just get 10 to the first minus 3 times f prime of 1 over f of 1 minus arctangent of 1, all right? And so right here, you cannot leave this. Okay, you have to do more than this, because f prime of 1, that is, it's not trivial as to what f prime of 1 is. And f of 1, I mean, I personally think it's trivial, but some people don't. So f of 1, you obviously can't leave that. And then arctangent of 1. I'm trying to think.
Mrs. Gordon said that trig does need to be evaluated.
Okay, that's what I thought. So you have to evaluate arctangent of 1. All right, so you do this, obviously 10 to the first minus 3 times f prime of 1. F prime of 1, remember, is pretty easy. That's just, you remember, you're looking at a graph of f, and f prime of 1 represents the slope, right? And so you were told that this is a line, so you just need to figure out that slope. And so the slope is 2. All right, and so you get 10 minus 3 times 2, and then f of 1, remember, you're looking at a graph of f, so you're just looking for the y value when x is 1, so that's 1 minus arctangent of 1. Remember, arctangent of 1 really means what? Tangent of what angle is 1, right? And remember, tangent must be a value in between negative pi over 2 and positive pi over 2, and so that answer has to be pi over 4. Okay? All right, any follow-ups with part D? All right, so let's move on to.
Oh wait, before you go, how we evaluate f of 1? Because I get f prime 1, but just how we evaluate f1.
Oh, sure. This is a graph of f, right, that we were given initially. And so f of 1 is just the y value when x is 1. So it's just 1.
Oh, my bad.
Right? Like if I said, no, it's one that people miss. Like, so if I said, what is f of 0, that would just be negative 1. Or what if I said f of 2, that would be 3, right?
Mhm.
So that's it. Yeah, I mean, it's one that people get wrong, but it's pretty simple. It's not even calculus, but people get tripped up on it.
All right, thank you.
All right. All right, so that is question 1. All right, anything else with question 1? All right, then let's move on to the second question. All right, functions f, g, and h are twice differentiable functions with g of 2 equals h of 2, which equals 4. The line y equals 4, what is that, a minus? I got to pull up my other document, sorry.
I think it's supposed to be plus.
Is it a plus? 4 plus 2/3 x minus 2. Okay. Things are just going really slow on my computer right now. Guess I have too much stuff happening. All right. So you're given that line, and then it says it is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. All right. And so A says find h prime of 2. All right. So remember, you are just given the equation of the line tangent to the graph of g and of h at x equals 2, right? And so what does that mean? Well, that means that this is the equation of the tangent line. And so h prime of 2, very simple, you know that h prime of 2 means the slope of the tangent line. And so the slope of the tangent line is the slope of this line. So very simple, the slope is 2/3. So no work or anything to do there. You're just recognizing what that is. Questions on part A?
Could we just distribute and take the derivative?
Well, yeah, but remember, it's just a line, right? So if I distribute, right, I get 4 plus 2/3 x minus 4/3, right? And then I have y equals 2/3 x, and then 4 minus 4/3, right? So that would be 12/3 minus 4/3. 8/3, right? So we're really just looking at the slope, right? Just 2/3. I mean, you don't have to take the derivative, right? It's just a line, right? So when you're in y equals mx plus b, you're just getting that slope is 2/3.
All right, thank you.
So when I did it, I didn't even do any of that work. I just looked at this and realized that 2/3 was going to be the coefficient of x when I simplified it. So I just kind of left it like that.
All right, thank
Okay.
you.
All right. Anything else with part A?
Completely was overthinking about this because I just was panicked. I wanted to see if I can find a straightforward answer, but when I looked at the answer sheet, I realized, wait a second, the line, the function we're given for the line, if we actually put that into point like y minus y1 is equal to mx minus x1 form, then
Yep.
Yeah, you can just m tan is equal to slope and 2/3, and then realize, wait, h prime 2 and g prime 2 are equal to 2/3, and that's
Right.
Yeah,
Okay.
that's how I got the answer.
Yeah, that's good. All right. So for B, all right, B says let A be the function given by a of x equals 3x cubed, h of x. Find an expression for a prime of x, and then find a prime of 2. All right. So first of all, a of x, I just wrote that down, and then I found the derivative. Now remember, this is just a product, right? 3x cubed times h of x, and so I use the product rule. 3x cubed times h prime plus h times 9x squared, right? So that would be the first part. All right, and so looking at the rubric, all right, all right, looking at the rubric, you've got the product rule here, right? And then you've got a prime of x. So actually getting that, you're getting 2 points for this question, for that part, right? And then it says find a prime of 2. So now I'm plugging in 2. So when I do this first line, I have 3 times 2 cubed times h prime of 2 plus h of 2 times 9 times 2 squared, right? So if I have this, I don't get the point for a prime of 2 yet because I have to give h prime of 2 and h of 2, all right? And so I have 3 times 8 times 2/3. H prime of 2 was what we found in A, right? And then plus 4, which is h of 2, which we were given, times 36. I do not have to simplify from here. If I left this alone, that is just fine. Okay.
If
now,
you used your answer, oh, sorry.
Yeah. So you're going to say if you used your answer from A, even though A was wrong, do you still get credit in B?
Yeah.
Yes.
Exactly.
Yes, you would. And so, for somebody who for some reason couldn't figure out what A was, right? I would make up an answer. I would just put like 5 or -2 or 0 or whatever, right? So you just make up an answer here. And then if you use that answer correct down here, then you're going to get the credit in B for that part. You won't get A, obviously.
Could you use like 0 and then like have like an easier like time?
Yeah, I mean, I suppose you could. I generally wouldn't use 0 because, like, let's say that we were using like the quotient rule or something, and then it was going to be in the denominator, and then I don't know if that is weird or whatever. I would use like 2 or something like that.
Okay.
Yeah, sometimes 0 and 1, can make a problem turn out in a weird way. So if you were making up an answer, I would pick some other number. Okay. All right, so that's part B. Anything else with part B? All right, so now part C was kind of a weird one. All right, so it says the function h satisfies h of x equals x squared minus 4 divided by 1 minus f of x cubed for x not equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. All right, use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answer. All right, so the first thing that we have to remember, all right, is that if you could evaluate this limit, right, using L'Hopital's rule, right, what does that mean? Okay, that means that the numerator must be approaching 0 and the denominator must be approaching 0 individually, right? Okay, that also means that the numerator and the denominator are continuous and differentiable functions at x equals 2. Right, so that is important to note, okay, because, all right, if the numerator is approaching, as x approaches 2 equals 0, well, that's obviously true, right, because the limit as x squared minus 4 as x approaches 2 does equal 0. But the denominator, right, you don't know what f of x is. So you can say that since the limit as x approaches 2 of 1 minus f of x cubed equals 0, right, that tells you that you could say, well, the limit as x approaches 2 of 1 minus the limit as x approaches 2 of f of x cubed equals 0. And then you could add that over, right? And you could say that the limit as x approaches 2 of 1, which is just 1, is equal to the limit as x approaches 2 of f cubed. Right now, remember, way back in chapter 1 or unit 1, we talked about this. If you have the limit of something to a power, you can bring the power on the outside of the limit. So you could say the limit as x approaches 2 of f of x cubed is going to equal 1. So if you cube root both sides, you get that the limit as x approaches 2 of f of x is 1. Okay, therefore, f of 2 is 1, right? How do I know that? Once again, well, remember, because at the very beginning, we were told that f, g, and h are twice differentiable. So what does that mean? Remember, twice differentiable means that the first derivative exists and the second derivative exists. So if the first derivative of f exists, that means that f is continuous, right? And if f is continuous, that means that the limit as x approaches 2 must equal f of 2, right? And so this limit as x approaches 2 of f must equal f of 2. So that means that f of 2 equals 1. All right, so that's the first part. All right, the second part then comes from evaluating this limit as h. All right, so now this is the limit as x approaches 2 of h, right? But remember, you were also told that h of x is twice differentiable. Therefore, the limit as x approaches 2 equals h of 2, and h of 2 you were given at the beginning that equals 4. And so I set this limit equal to 4. Right now, because the numerator and denominator approach 0 separately and they're continuous and differentiable, I can use L'Hopital's rule. So I take the derivative of x squared minus 4 to get 2x, and I take the derivative of the denominator to get negative 3f squared times f prime. And so now I know that this limit equals 4, right? And so when I plug 2 in, I get 2 times 2 equals negative 3 times f of 2 squared times f prime of 2 equals 4, right? That's what I have here. And now I just need to do some algebra to solve for f prime of 2. So I multiplied both sides by f prime of 2 and divided both sides by 4. And I simplified and I got negative 1/3. So f prime of 2 equals negative 1/3. All right, so that is a 4-point question. So you get 1 point, according to the rubric, you get 1 point for setting the limit as x approaches 2 of h equal to 4, okay? You get 1 point for finding f of 2. You get 1 point for using L'Hopital's rule, and then you get 1 point for finding f prime of 2. So it's a 4-point question. So a pretty valuable question, but you know, not, I mean, I know I wrote a lot here, but there's really not a ton of work to do there. Okay, any follow-ups with part C?
How do we know that the limit as x goes to 2 of 1 minus f of x cubed equals 0?
Right here?
More to your right, upper right.
Oh, right here.
Yeah, right there.
Okay, because you were told that the limit as x approaches 2 of h can be solved using L'Hopital's rule. right? And so L'Hopital's rule says that the numerator, right, the limit as x approaches 2 of the numerator must equal 0,
Yeah, I
and
get
the
that.
limit as x approaches 2 of the denominator must equal 0. Right?
Oh,
If you use L'Hopital's rule, you had to have gotten a 0 over 0 or an infinity over infinity, but obviously we're not approaching infinity, so it has to be 0.
Oh, I see.
So would they do a trick question where it's like use the rule and then like it doesn't equal 0? Like, well, they won't have that.
Well, no, because the problem told you that this limit can be solved using L'Hopital's rule. So this stuff must be true, because
Okay.
that is what must be true in order for L'Hopital's rule to apply.
Okay.
Okay? Anything else with part C?
Can you go down a little bit on the paper?
Sure.
All right, I'm good.
Okay. All right, so that is part C. All right, and then part D. It is known that g of x is less than or equal to h of x for x between 1 and 3. Let k be a function satisfying g of x is less than or equal to k of x, which is less than or equal to h of x for x between 1 and 3. Is k continuous at x equals 2? Justify your answer. All right, so remember, definition of continuity. What does that say? That the limit as x approaches 2 must exist, and the value of the function must exist, right? And so what we're trying to show is that k of 2 exists, and the limit as x approaches 2 of k of x exists and is equal to k of 2. It changed my camera, huh? You guys aren't seeing my paper anymore. Oh, here it is. You good? Okay, I'm sorry, I didn't know why it changed. All right, so we're just trying to show that this is true, right? And so now, if we know that k of x is always in between g of x and h of x, right? So like if I draw a picture, let's say like we have g of x here and, oh, sorry, that should be h. So let's say here's g of x here and h of x here, right? So h is up here, g of x is down here, right? Now, you know that both of them have the same y value, right? Because you're told h of 2 and g of 2 is 4. So this is at 2, 4, right? And then they have the same line tangent to them, right? And so basically we're saying k is some function that is always in between or equal to the 2. So it would have to be true that k of x would go through there as well, right? And the limit as we approach that value has to be that value as well. So it's really like, I don't know, I don't think it's really that profound when you think about that picture, but it's a question, you know, that they have asked in the past. Obviously, this is just from 2019, so it is something, but it's only 1 point, right? And so basically, you're just saying yes, it's continuous, and you have some sort of justification for it. Any follow-ups?
They said because of the squeeze theorem. What is that?
I mean, it's basically just what we described here, where as h and g get closer and closer together, k has to continue to be in between them until they're equal, right? And then k would have to be equal to them because you were told that k of x is greater than or equal to g of x and less than or equal to h of x.
Okay, sounds good. I also have another question about A.
Sure.
So the line at the beginning, it says the line y equals 4 plus 2/3 x minus 2. I
Yep.
thought that meant that like that is what m is, like that's what the slope is. So I plugged in.
Oh, you thought that this equation was the equation for the slope.
Yeah, like I
Okay.
don't know why
Now,
it's not.
so yeah, so what it says is the line y equals 4 plus 2/3 x minus 2 is tangent to both the graphs. So that's the equation of the tangent line.
Okay.
Mr. Bonrigo, question in part D, could you use the picture as a justification?
If you just drew the picture, probably not. You would have to state, something about these two limits, and the fact that those are continuous. So the limit as x approaches 2 of g must equal g of 2, which is 4, and the limit as x approaches 2 of h must equal h of 2, which is 4. Therefore, the limit as x approaches 2 of k must also equal 4. So you really have to state something, in my opinion, about like the definition of continuity.
Additionally, I can't think of any time really, and I know it happens a lot when we're doing these FRQs, where a graph is really like a solution to a problem. You're pretty much always going to be writing either something mathematical or writing things about limits, continuity. A graph or a picture is something that you could use to help you think about things, but it's never really an answer to the question, unless the question were to draw a slope field. 10-5.
The key is to follow up on that is that a graph that you draw is just a kind of a representation of what could be going on, but you don't actually know what the graph of h and g look like. So drawing this graph and saying this is the graph of h and g is not correct.
Also, that just reminded me, and I don't know if we've seen problems where this has been an issue yet, but if you're ever referencing a graph that is given, you cannot use the words like the graph or the picture. You need to refer to it as the function. So like in problem 1, if you were going to talk about the function f, you can't say like the graph is doing this. You have to say like function f is increasing on whatever.
Yeah. Okay. Any other follow-ups? So just a reminder to you guys, I know you guys are on this call, but it would be helpful for you guys to, disseminate this information to your friends and classmates and things. And both Mr. Davis and I put a comment on our Schoology pages as well. But the goal of these FRQs is to give you guys practice and try to help you understand the things that you don't currently know. And so, we know that you guys are at home and that you have access to the internet and you have access to your notes and all of that. The goal of these is to give you guys practice and help you guys to realize some of the things that maybe you don't know. And so if you guys are, chatting with other people when you're working on these or searching on the internet for answers and things, you're really not helping yourself all that much. And I know a lot of people are driven by like grades and things. And I think you want to throw grades out the window at this point. We're really just trying to make sure that you guys are going to be prepared for this AP test. So, tell your friends, like if people are like, hey, how did you do this problem? Like, it's really in everyone's, in any individual's best interest to, just try their best on a problem, get an answer on paper, and then when we share the solutions and we answer questions, then say, oh, okay, now I know how to do that. And maybe the next time you try a problem like that, you'll be able to do it better on your own. But I think people who are, kind of searching around on the internet for solutions are really not going to put themselves in a great position in just over a month to do well in the AP test. And so like Ben says, should we use our notes in the actual AP test? Yeah, obviously you can have your notes and things available, but if you're, searching through your notes, furiously, you might be running out of time, right? So the reason we're giving you all this practice is so you're not going to have to use your notes. It's just going to be in your mind. You're going to know how to do the problems, but you're not going to get to that point unless you're actually putting in the time and effort to try these problems without somebody's help or without searching on the internet for an answer, because AP has been very clear that these questions are not going to be ones that you're going to be able to like Google search, and you're not going to be able to work with other students because everyone is going to have a different test. So like if Brenna gets a question and then she's like contacting Luca, like, hey, how do you do this problem? Luca's going to be like, leave me alone. I'm taking my own test and I only have 45 minutes to do it. So it's super important that you guys remember AP is very reliable in distributing tests, and they have plans in place to guarantee that people are not able to cheat. And they have been very clear that if they do discover people cheating, and people will try to cheat, then those students will automatically receive a 0, and their any colleges that they apply to would be notified that they cheated on an AP test. And for a junior or something like that, any attempt to take another College Board managed test could be in jeopardy. So that would mean any AP tests in the future, and SAT, things like that. So it's really not something that anybody wants to risk. Any follow-ups?
Kane had a question about if the questions are different, how the curve will work.
That's a good question. The way that this works is on volume. And so, if they have so many different versions, so like, let's say that we have 70 students, or 80 students at RB that are taking the test, right? And there's so many different versions. So maybe only like, 2 students have, a similar question, and 2 other students have a similar question, right? But, if there's, let's say 50,000 students who have taken the same question that somebody else took across the country, they can still have a pretty good normal distribution of scores on those questions. Does that make sense?
I think we're still gonna have our finals when we have these AP tests.
Are we gonna like have finals at RB?
Yeah.
They haven't officially announced anything, but I think it's pretty unlikely. Anybody else?
Number 2C.
2C? The one with L'Hopital's rule that I just went over?
Yeah.
Okay, what else do you want to know about it?
Just need to look at the information.
Okay. And there's videos for all of these as well. So if you want to, view those videos, you can do that.
Where are those videos? Because I
in the Schoology folder.
I checked the materials for today, and I couldn't find anything anything video related. I just found the answers and the agenda.
If you looked in the folder, all the videos they're right next to them. So go to Schoology, go in today's e-learning folder, and you should see another folder that says solution videos.
I just checked. Yours is actually unpublished.
My videos?
Yeah, so I'll publish it for you.
Thanks.
No problem. There you go. So they're there now, David.
That's annoying. Sorry about that. All right. Any other questions?
I think another question I have is how to performing the critical number test in 1C. How exact? I know that G prime 2 late if for any integral with 2 negative numbers that are same, it's automatically 0. But how exactly do I calculate?
Not 2 negative numbers, but if they're the same number.
The same number. Yeah, for using g of x is equal to the integral from -2 of x f t dt. How exactly does that calculate out?
So, okay, so g of -2, that one's easy, right? Because that's just 0. But if I have g of -1, remember that's the integral from -2 to -1, right? And so if you look at the graph, we're just looking for the area under the curve from -2 to -1. So that's just the area of that triangle.
That's for sure. So geometric area.
Yep.
I'm given a graph of f of g, and if I don't necessarily have a function to work with, I just look for geometric area. That's probably the problem why I had so much trouble with number 1, because I never thought about using
Yeah.
geometric area for
Yeah.
areas
Yeah, that is a
above or below the
big
curve.
part of that. Yep. All right.
I think that's all I need to be here for. I'll check again for the videos and see
Okay.
if I can clear up some other questions I have about this FRQ, and I will see all of you later.
Okay, of course. All right, and everybody, if we're going to have 2 more FRQs tomorrow, so if you can just, tell your friends like, hey, got to try it on your own. Let's, and then the following day we'll put out solutions and videos and everything, and and do another Zoom call on Thursday to give everybody an opportunity to really try some more questions. Okay.
All right. Seems like these FRQs.
I have a question. We don't have anything due today, right? It's just
Nope.
like looking over the thing. Okay.
Correct.
Looks like a lot of these FRQ questions, especially with this FRQ, love to go back to Unit 7, which is something that which is not my which hasn't really been my strong point for the entirety of calculus.
Yeah. Well, keep trying every day. Keep showing up and asking questions, and watch all the videos that are out there. All right.
All right. I guess this is where I leave, because I think I have another Zoom meeting with my science teacher.
All right. All right, everybody. Have a good day, and we'll probably see you on Thursday then.
Yeah.
Bye all.